Agena is now approaching the west coast of the United States, Mexico, Baja California. And it will actually be about 1,009 nautical miles ahead of the Gemini at the time of insertion. It won't be quite that far ahead at the time of liftoff, but it will be ahead of it a little bit. And number 8 should be about 480 nautical miles behind it. And we'll have the three things whirling around up there together. Hopefully all of them sufficiently synchronized so that they can carry on the remainder of this mission. They had all the good luck with number 10, and they've had no problems in the countdown with with the spacecraft. So it should work out all right, but it is staggeringly complex.
Hello and welcome. This is Michael Annis, and you're listening to episode 81 of the Space Rocket History Podcast. And now, Gemini 10 with John Young and Michael Collins, Part 2. We left off last week just after the successful launch and orbital insertion of Agena 10. 100 minutes after the Atlas Agena launch, it was time for the Gemini 10 launch. Here's Gemini Launch Control explaining a planned 3-minute hold before launch.
This is Gemini Launch Control. We're at T-minus 3 minutes and holding. T-minus 3. Just as this announcement came up, the hold was declared. This is the planned built-in hold. The duration is about 5 minutes and 35 seconds. We will then resume our countdown at T-minus 3 minutes, aiming for ignition of the launch vehicle at 20 minutes and 23 seconds after the hour. We have a window, a period in which we can launch of about 37 seconds. This is the launch plan at the present time. Following resumption of the count, some very important information will be going to the launch vehicle and spacecraft. These are the update flight parameters. The launch vehicle guidance system, of course, is the primary system that directs the vehicle during the powered phase of flight. We send a signal by hard line here at the Cape to the launch vehicle to put in the proper parameters. By radio signal, we send flight parameters also to the Gemini spacecraft computer, which acts as a backup guidance system in the event the primary system fails during flight. If, as on the Gemini 9 mission, the spacecraft computer does not receive the update signal at the T-minus 3 minute mark, we will continue with our countdown because the computer has information that was stored aboard at T-minus 15 minutes in the count. If the spacecraft computer does accept the information, we will make a check to ensure that this information is correct as we continue down the final 3 minutes of the count. We're holding at T-minus 3 minutes. This is Gemini Launch Control.
And now, with the hold completed, the countdown has resumed.
This is Gemini Launch Control, T-minus 1 minute and 50 seconds. We now have confirmation here in the control center that the updates received by the launch vehicle and spacecraft are correct. We are in a go condition at this point in the countdown. During the final moments of the count, the vehicle will go on internal power on its 2 batteries in the launch vehicle at 1 minute and 30 seconds. Right at this point, T-minus 90 seconds and counting. Some 10 seconds from now, the engines will be gimbaled. Once again, as a final check, the launch vehicle test conductor will alert the astronauts that this event will take place because they can actually feel it in the spacecraft itself. Now 1 minute and 11 seconds and counting. Most of the work in the blockhouse at this point is all monitoring the various consoles. We are in a completely automatic sequence. Now T-minus 60 seconds and counting. T-minus 50. T-minus 40 seconds and counting. During these final moments of the count, the pre-valves in the launch vehicle will open to permit the fuel and the oxidizer to come down toward the chamber of the vehicle. 30 seconds and counting. T-minus 20. Quick check on the blockhouse. All systems looking good. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2,
has started. Front looks good. T plus 20 seconds. Roll program complete. And the pitch program has started. Seconds into the flight, Gordon Cooper advises the crew they're looking mighty good. We have the proper roll and pitch programs in, and both guidance systems are go. Cabin ceiling at 5.7 pounds. Mark 1 minute. Spacecraft clocks are in sync. One minute, 15 seconds. One minute, 30 seconds. 40 miles in altitude. Surgeon reports the crew looks fine to them. One minute, 45 seconds. We're 120 miles downrange. The crew reports an update has been received in the spacecraft. Minutes, 4 seconds. And the crew has been given a go for staging. And 10 is go for staging, Young reports. 2 minutes, 20 seconds. Crew reports they received another update. And we've got first stage cut off. Flight dynamics confirms staging. And second stage thrust looks good. Young says his guidance displays look good on board, and they look good here in this control center. 3 minutes, 12 seconds into the flight. We're 120 miles downrange, approximately 60 miles altitude. 3 minutes, 30 seconds. Guidance says both guidance systems are exactly what they ought to be. Mark 4 minutes. Final status check being taken now by the flight director, Glenn Lunny. He gets a go from every station and tells Gordon Cooper to give 10 a go. And Young reports he is also go. 4 minutes, 24 seconds into the flight. 5 minutes, 16 seconds into the flight, and we've achieved 80% of the desired velocity. We're now reading a little more than 21,400 feet per second. Cooper checks with Young to be sure they receive that 0.8 mark, and Young says, we got it. Very little conversation coming back from the crew. Good Seco. There it is, 5 minutes, 46 seconds. On range, 87. Lunny says your go all the way to proceed with the IVAR routine, the insertion velocity authority routine. And the crew, the spacecraft is firing its thrusters. Young says we look good. They're leaving the second stage. Collins now reading some numbers out of his computer on board. The solutions compare very favorably with the ground situation here, calling for a 25 feet per second forward burn, and that is what Young is executing. 6 minutes, 53 seconds.
The Titan launch vehicle boosted the spacecraft skyward exactly on time, Except for a slight shaking and buzzing in their ears, Young and Collins had a nice ride to start chasing their first target, Agena 10. After entry into orbit, Gemini 10 trailed its Agena by 1,800 kilometers. Flight Director Lunny told the crew that they were all set for a fourth orbit rendezvous. Collins unstowed a Colesman sextant to sight on selected stars for an attempt at optical navigation. Young pointed the spacecraft while his crewmate tried to find the horizon. Collins realized that he was using the wrong reference when he saw stars below the line. He had been mistakenly using the air glow, a band of radiant light from the upper atmosphere, for the horizon. Even after he had corrected this, Collins could not get the lens of the sextant to work properly, as the optical image of the stars did not agree with what he had been taught. He laid the Colesman aside and tried an Eilon instrument, but that was little help, as the Eilon had a severely limited field of view. Young and Collins checked their figures with Lunny, the flight director, who had been watching their activities carefully through telemetry. When the trio found that the numbers did not agree with those of the ground computers, Gordon Cooper, the Houston Capcom, passed the word that the crew would have to use the ground computations. Young then fired the thruster to adjust their orbit to 265 by 272 kilometers. When Young aligned the platform for a terminal phase, he did not realize that the spacecraft was turned slightly. As he thrusted toward the target, Young needed two large mid-course corrections. The spacecraft path toward the Agena was not lined up properly, so he had to stop thrusting briefly and take off on a new track. The final translation maneuvers to reach the Agena cost nearly 181 kilograms of fuel, or 3 times more than any earlier mission. 5 hours and 52 minutes after launch, Young and Collins successfully docked with Agena 10. Now it was time to perform some docking practice maneuvers. But there was a problem. Too much fuel had been used. Flight Director Lunny decided to omit docking practice. While backing away and then returning to the Agena's cone, Young and Collins wondered if the second rendezvous might also be canceled because of the low fuel. But some 6.5 hours into the mission, the ground controllers started giving the crew the data they would need for the burn. Then, an hour later, the Capcom at Hawaii cleared them to try for a second rendezvous, which would be with the Gemini 8 Agena. You may recall from episode 80 that the Agena 10 engine was to be used to push the Gemini capsule up to the higher orbit of the Gemini 8 Agena. With the Gemini 10 spacecraft docked to the Agena 10, the Agena engines were started exactly on time. Here's the clip.
Start C. SPS ready. SPS initiate. When that baby lights, there's no doubt about it.
For 80 seconds, the target vehicle thrust the spacecraft upward, adding 129 meters per second to their speed. The crew at the moment flying backwards had little to say about their reactions to a negative 1G force. In other words, it was like a shove to the front of the body, eyeballs out, rather than a push on their backside, eyeballs in, as during launch. They were thrown forward from their seats against the body straps. This is how Young described the first ride on an Agena engine. Quote, "At first, the sensation I got was that there was a pop in front of our eyes. Then there was a big explosion and a clang. We were thrown forward in our seats. We had our shoulder harnesses fastened. Fire and sparks started coming out of the back end of that rascal. The light was something fierce, and the acceleration was pretty good. The vehicle yawed off. I don't remember whether it was right or left, but it was the kind of response that the Lockheed people had predicted we would get. The shutdown on the primary propulsion system was just unbelievable. It was a quick jolt and then the tailoff. I never saw anything like that before. Sparks and fire and smoke and lights." End quote. Gemini 10 reached an orbit that measured 763 kilometers at the top and 294 kilometers at the bottom. The Agena had pushed the spacecraft more than 463 kilometers above its initial apogee. Young and Collins now viewed Earth from a higher elevation than any human beings ever had. Instead of gazing at the planet in wonderment, however, they confined their attention to their own little artificial world. They watched spacecraft systems and kept an eye on the radiation dosage readings, which were within tolerable limits. During his technical debriefing, Young only reported, quote, "We took some pictures at apogee. I don't know where it was, but it shows the curvature of the Earth. We took some pictures coming downhill. I think it was the Red Sea area." End quote. Thus, in rating one impression over the other, record altitude versus Agena ignition, Young and Collins were more affected by the firing of the Agena engine than they were by the unique vantage point they had reached. This lack of awe at their record height was caused, at least in part, by the fact that the Agena engine blocked much of their downward view. 9 hours into the flight, the pilots bedded down, sleeping fitfully. Both were still wondering if the second rendezvous would be done. Besides, neither astronaut was really tired. Flight Director Charlesworth's shift in Mission Control was busy that night, reviewing alternate plans for adapting the mission to fulfill its objectives. When Young and Collins ended their rest period after 18 hours of flight, their spirits lifted as the Capcom station at Carnarvon gave them the numbers for the next target vehicle firing. With the Agena spacecraft combination faced about so the main engine would fire directly into the flight path, Young made a 78-second burn to reduce the velocity by 105 meters per second and lower the apogee to 382 kilometers. The pilots were again pressed forward in their seats, but this time they were impressed more by the firepower of the Agena than by its fireworks. Young commented, quote, "It may be only 1G, but it's the biggest 1G we ever saw. That thing really lights into you." End quote. Like rendezvous maneuvers in the past, the next Agena burn, and the final one with the main engine, aimed at circularizing the orbit. At T plus 22 hours 37 minutes, the target drove the spacecraft along the flight path to add 25 meters per second to the speed. This brought the low point of the orbit to 377 kilometers, only 17 kilometers below Agena 8. Although rendezvous and docked maneuvers with the Agena were the high point of the first day, the crew also spent a good part of that time on 14 experiments they carried. 20 minutes after launch, the crew turned on a switch to start the tri-axis magnetometer, experiment MSC-3. This device was used, as it had been in other flights, to measure the radiation levels in the South Atlantic anomaly. 2 other experiments were also devoted to radiation. MSC-6 beta spectrometer mounted in the adapter to measure potential radiation doses for future missions, and MSC-7 Bremsstrahlung spectrometer installed in the cabin to detect radiation flux as a function of energy when the spacecraft passed through the South Atlantic anomaly. Some of the experiments had to be done outside the spacecraft. Before the third Agena burn, Collins got ready for his first exposure to outer space, a stand-up EVA. Preparations went well, and the hatch opened easily. At sunset, Collins stood in his seat, setting up a 70mm general-purpose camera for Experiment S-13, a photographic study of stellar ultraviolet radiation. Collins aimed the camera at the southern Milky Way, scanning from Beta Crucis to Gamma Velorum, and exposed 22 frames. The entire night pass was devoted to this task. Young helped Collins identify the stars while at the same time controlling the spacecraft and target vehicle combination. With the beginning of daylight, Collins began Experiment MSC-8, color patch photography, to see if film would accurately reproduce colors in space. Collins did not complete this assignment, however, as his eyes began to fill up with tears. Young had the same problem. They suspected at first that the anti-fog compound inside their faceplates was irritating their eyes. They decided to close the hatch at T plus 24 hours 13 minutes, about 6 minutes early. The astronauts had noticed a strange odor that they thought might have been the lithium hydroxide used in the environmental control system. But ground engineers finally concluded that their eye irritation was caused by having both spacesuit fans on at the same time. They turned one fan off, and at 30 hours elapsed time began a second sleep period. Bone tired this time, they rested well. Young and Collins awoke to a morning of increased activity. In addition to their normal system check, the ground network also reminded them of the experiments expected this day. The S-26 ion wake measurement to study the ion and electron structure of the spacecraft's wake after it undocked from the Agena. The S-5 experiment, synoptic terrain, and S-6 experiment, synoptic weather photography. The astronauts also had to work in 2 maneuvers to help them catch up with the Agena 8. The Agena 10 engine had accomplished its task. After being hooked to it for 39 hours, though, they were getting a little tired of looking at it. Young said that watching the Agena out his window was just like backing down the railroad track in a diesel engine looking at a big boxcar in front of you. The drawback of having the Agena up there is that you can't see the outside world. The view out the window with the Agena on there is just practically zilch. Upon freeing themselves from the Agena, the crewmen began preparing for Collins' exit from the spacecraft. Young now needed to make the final maneuvers to get the spacecraft close enough to the Agena 8 for Collins to reach it. Collins connected the 15-meter umbilical to his suit and fastened it out of the way until time to use it. At T plus 45 minutes 38 seconds, Young sighted an Agena. At that moment, it looked blurry. After the distance between the two vehicles had been calculated, The Houston Capcom on the remote line through the Canton station informed Young that their range to the Gemini 8 Agena was 176 kilometers. The crew then learned that what they had been looking at was their own Gemini 10 Agena, just 5.5 kilometers away. Houston radioed, 176 kilometers is a pretty long range. And Young answered, "You have to have real good eyesight for that." The astronauts didn't see the Gemini 8 Agena until it was 30 to 37 kilometers from them, looking to Young like a dim star-like dot until the sun rose above the spacecraft nose. NORAD's constant care had paid off. They found Agena 8 just where it was supposed to be. Here is the clip.
See anything of the Agena 8 around?
Yeah, we're about, I guess, 700-800 feet out.
Fantastic, John.
Yeah, I don't believe it myself.
Believe it, John, you found it. At T plus 47 hours and 26 minutes, Young started the final closure, with Collins computing the figures for 2 mid-course corrections. The crew found the old Agena pretty stable, and Young moved in to station keeping about 3 meters above it. In less than 30 minutes, he told the Houston Capcom that they were going down for a closer look at the micrometeorite collection package. Back in Mission Control Center, fuel usage during station keeping was being very closely watched. When it proved to be reasonable, Gemini 10 received a go for the next EVA. Young replied, quote, "Glad you said that, because Mike's going outside right now," end quote. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.